So let's get started. I want to introduce today's presenter, Mr. Keith Nagle of Phoseon Technology. Keith's been around the industry for quite some time. He's been in a lot of different roles. Keith is a great friend of the FTA. He's always there to help us out when we need it. He's been, like I said, been in multiple roles. He's been an ink guy. He's been a press salesman. He currently is the business development manager or director for Phoseon. But more importantly, Keith is fresh back from Charlotte, where he was our Fall Conference 2019 chair. And I got to tell you, Keith did a great job, and I'm pretty sure he's going to do another great job here today. So Keith, are you there?
I am here.
And I'm going to let you go ahead and steal the screen share away from me.
All right. Thank you very much for the introduction, Joe. Very excited to be here and talk a little bit about a new technology it's been around, but it's still fairly new to the industry. So we're going to spend some time talking about LED and then where it fits within Flexo and how it can improve some of your processes and what you're doing today. So the key thing here is, Flexo is better with LED, but the message that I want to get across is the time is now. It's been around for about 15 years in our industry, and it's been a slow adapter, but it's quickly gaining some interest. And once people are getting to see what it can do for them, they're quickly adapting it into their technology. So with that, we'll get moving a little bit here. So a little bit about the company that I work for, Phoseon Technologies. We've been an LED pioneer since about 2002. We're 100% focused on LED. We do not do any other kind of curing or drying technology. We do not have mercury, UV. We do not have IR dryers or anything like that. We are only an LED company. We have over 300 patents on technology, so that protects us and that protects our converters. We've shipped over 100,000 units, supporting about 25 million LEDs around the world. We're in a lot of different markets. I'm going to talk about Flexo to you today, but we're also in some other industrial curing applications like fiber optic coatings for fiber optic lines. We do wood coatings, floor coatings. We also have a division of our company that is in the medical sciences for like medical sterilization with LED. So we do a lot of different things, but the part that I'm very focused on and I'm excited about is the Flexo portion of it. We have 10 offices worldwide, and we're headquartered in Portland, Oregon. Our corporate offices are in Oregon. We also have all of our R&D and manufacturing in Oregon. So everything is made and serviced out of Oregon, but we do have 10 offices around the world. So this is a telling graph here. It was a study that came out in 2018 by Yole, and it was a UV LED, the adoption rate of UV LED in industrial curing applications, right? So if you look at as the trend goes, it shows UV, regular mercury UV, the dark orange, is continuing to grow, but the rate at which LED, which is the lighter orange bar to the right, is catching it is significantly faster. And what I would anticipate, knowing the market, if you were to push this graph out a couple more, like 2020, like 2024, 2025, 2026. Somewhere in that area, you're going to see where LED actually bypasses mercury, and mercury begins a downfall. The reason being is there's quite a few things that go into that. There's the health and safety aspect of it, the environmental aspect of dealing with mercury, but there's also economies of scale that are playing in here. Right now, it's still less expensive to deal with a mercury bulb than it is with LED. But if you think about the market, total LED market, TVs are going to LED. The lighting in your houses are going to LED. The municipality that I live in Cincinnati, Ohio, just converted all of their traffic lights and street lights to LED. Walmart, all of their lights inside are LED. So as the lighting industry as a whole moves toward LED, it actually becomes more or less expensive to go that route. So the economies of scale are actually going to flip towards less expensive to produce it and work with LED, and it's going to be more expensive to work with mercury. So I anticipate in the next 2 to 3 years out of what you see here on this graph would be a flip where LED would take over mercury. So what is an LED? It's a solid state semiconductor device. It produces light when an electrical current flows through it. It flows from the positive side of the circuit to the negative side. We call that the PN junction. LED output is increased over time. This is important, but it's more array optics and thermal management design. So the chips that we get today, the graph on the right side, if you look at the yellow part, that represents the actual LED, right? So the difference if you look at the output that is growing, the impact has been significantly much more by Phoseon, right? So we take the same LED chips today that we've been getting for years, and we've been able to improve them by managing thermal stability, changing the optics, and working with the array to increase the output. So the technology itself really hasn't evolved from the LED standpoint as more as it has the manufacturers that are taking it and doing things with it that is allowing it to output more without affecting the lifetime of the light itself. So we take these LEDs at Phoseon and we arrange them in an array. We call it an SLM, which is a acronym for Semiconductor Light Matrix. We source the raw LED. We do not buy prepackaged LEDs. We're one of the largest consumers of raw LEDs in the industry. If you remember back to the previous slide, we've done over 25 million LEDs in the marketplace. We use these to create a patented array that provides uniform UV output across the SLM itself. So the proprietary patented semiconductor light matrix, or SLM, combines carefully sourced and sorted UV LED diodes into arrays that incorporate special optics, mechanical and electrical design, plus thermal management to maximize UV energy output and uniformity. So we get these raw chips in from the suppliers and we put them through a battery of tests. And then they're sorted by output and intensity and their availability and where they fit in the marketplace. They don't all come in the same, even though they all may say 395 nanometers or 365 nanometers. They have different capabilities. Phoseon determines which LEDs are used in an array based on similar optimal performance to achieve the most efficient combination and certain uniformity and maximum lifetime. Like I said, they don't all have the same output. So we will take what we would consider like a 395A and a 395B and put them in different arrays. That way that they're all uniform amongst the SLM. Hope that makes sense. So the wavelength availability within UV LED from Phoseon and pretty much the LED marketplace, we have 275 nanometers, which is UVC, UVC. And then we have 365, 385, 395, and 405. What you'll see is 90%, maybe even more of the Flexo market and a lot of other industrial markets have zeroed in on 395 nanometers. That was prior to my time in the industry. I could speculate that it has something to do with the photo initiator availability. It was very high for 395. There are a lot of popular photo initiators that are used in our market that react at that wavelength, and that may have something to do with it. It may also have something to do with the availability of the raw LEDs coming into the marketplace. One of the things you need to keep in mind is the materials must be formulated to take advantage of the narrow wavelength. So if you look at all these peaks on this graph down here, from left at 200 nanometers all the way to the right at 1800 nanometers, that's the light spectrum, right? So that's the output of a typical mercury UV bulb. 395 is right in the middle, and it's that very high peak that goes all the way up to the top. So we have a very narrow wavelength. We only use one wavelength in LED, where mercury uses multiple, from UVC all the way up to infrared. And we're able to achieve the same thing that you're doing today in Flexo by one efficient, stable LED. But what you need to make sure you do is convey to your ink supplier, your coating supplier, your adhesive supplier, whatever it may be that you're curing, that you are working with 395. Right? So if you do 395 and they send you 365, there is very little overlap in there. You may get partial cure, but you're not going to achieve the cure that you need to. The good thing is most of the industry is narrowed in on 395. There is some interest in the adhesive market for 365. And then all the way down to the left is that 275. That's that UVC range. UVC is something that is being talked widely about in the industry. One of the things with LED today at 395 is it's a very long penetrative wavelength that gets a very, very good depth of cure. So it's fantastic for opaque whites, metallics, blacks, everything that's traditionally hard to cure with mercury. The drawback is, the only drawback with the technology is that deep penetrating wavelength doesn't give you a very good surface cure. So with coatings, a lot of the characteristics with coatings are related to surface cure, and that's where this very short wavelength all the way to the left in that 275, 280 range will come into play.
Cool. Hey, Keith, we got a question.
Absolutely.
That's a good one. Does keeping to a narrow band of output reduce UV exposure safety concerns?
Yes and no. At the end of the day, you need to still treat it like UV light, but this UV light is far less intrusive than a traditional mercury bulb that has all of these different wavelengths in there.
Okay.
Yeah, you still need to treat it with some safety. You don't want to look directly into it. It's a bright light,
sure,
but it's not the same. It doesn't have the same effect over time.
And it doesn't have the heat too, right?
Zero heat.
Right.
So LED, yeah, and we'll talk about that a little more in the presentation. But LEDs actually do not put out infrared.
Okay.
So you see none of that all to the far right of this. There's very little visible light. If you look at the peak of 395, when it comes down, it kind of cones out and spreads out towards the base, and a little bit of that carries over into the visible light spectrum. That's why when you see an LED on a press, it looks purple, right? It looks almost like a black light. The reason for that is the far left section of visible light. If you remember back to school, Roy G. Biv, V is violet, and that's where the visible light portion of LEDs come from. So LEDs will put off a purple light.
Great. Thanks.
Any other questions? Is that okay?
Not yet, but keep them coming, folks.
Very good. So in reference to LED flexo presses, we've been in the market for quite a few years now. And globally, we're almost to about 300 presses that we are on around the world. And you can see there's a lot more in North America. North America has been the fastest to adopt that technology. And these presses could be a mixture of one LED for screen white, one LED for flexo opaque white heavy coverage, or one LED for a lamination application, or it could be 3 LEDs, 7 LEDs, or a full press. We have everything from 1 all the way up to 10. I think we actually have a couple presses around the world that have 12 LEDs that are all LED and no mercury and no hot air drying. So we've been on a lot of presses, and we've got a lot of experience in the marketplace. We also have relationships with every OEM supplier. You'll see a little further in the presentation. We work with all of the manufacturers of flexo presses. So if it's something that you're looking at as a new press with new technology, you can specifically tell whoever that may be, whether it be Neil Peter, Omet Gallus, MPS, Mark Andy, yeah, I'd like to look at LED technology, and we'd like to look at Phoseon, and that would not be an issue. So let's get into LED with flexo. It's rapidly expanding adoption, growing interest. And it's not just narrow web. We've actually got quite a few applications that are mid and wide web. We've got a very nice wide web application that we're working on right now with a converter. And if you think about wide web, it's got that big central drum, and there's a lot of energy from interstation UV or interstation drying. If you take out all of that extra energy and that extra heat, see the benefit of CI, one of the big benefits is actually very tight registration, because all of the print stations are on one drum, and there's no floating web in between stations. You take the heat away from that, and it becomes even that much better. So in the benefit with LED is it has a small form fit So it could fit in between the very narrow stations on a wide web CI flexo press. Once again, we're actually up to about 300 presses around the world, which represents somewhere around 90% of the share in the UV LED flexo market. According to the slide before, North America is leading the global adoption. There's a couple reasons for that. In North America, we're very fast to adopt new technology, whereas Europe right now, they're highly focused on low migration applications. And while low migration is fantastic with LED, the formulators have been slow to specifically formulate LED low migration historically. That has all been addressed, and today LED low migration is available around the world. And then with the Asian countries, they're very slow to adapt new technology. They like to bring it in, research it, dissect it, study it, analyze it, and put the data out, and then bring it in. So that's starting, but that curve to bring in the technology in that region has been very slow. UV LED units installed on new OEM presses and field retrofits. So like I said, we work with all of the new OEM manufacturers, but we also do field retrofits. So let's say you have a press in your facility that's been paid for and it's kind of back in the corner, and there's a handful of jobs that you run on it because the UVs don't run very well, or the hot air dryer just doesn't put out what it used to. And to retrofit and to bring those up to speed to get the production off of that press that you would need would be, fairly expensive process, right? With LED, we can bring it in, install it on the press, and pretty much rejuvenate that press. On top of the small form fit, the very low energy and power consumption, you're going to save on that aspect. There's low heat. So there's a lot of things you're going to open up the capabilities of these older presses in your facilities by making a simple LED retrofit. And with that, we offer air and water cooled LEDs. Each one offers a benefit, and they both have their drawbacks, if you would like to say. If I walk into a facility and I'm looking, the first thing I do is look at the facility itself. Is it a clean facility? Is it a dusty and dirty facility? And there's some parts of our industry that's just the nature of what it is. If you're in a carton facility, there's a lot of dust, carton dust. You want to kind of steer away from air cooled because there's the thermal stability portion of this is all about maintain constant temperature. And anytime that you've got air filters that could get clogged and they start drawing less air, that gives an opportunity for the temperatures to spike, which will affect the long time life of the LED. In those environments, I would probably recommend a water cooled LED. There's no air filters that you need to change. The drawback to that would be you have to include the price of a chiller. So with water cooled, we're able to push the peak irradiance a little bit higher. So with air cooled, right now we're up around 20 to 22 watts. With water cooled, we're up at 26 watts. And the reason we're able to do that with the exact same LEDs is because of that water, that chilled water that pushes through there, maintains a very consistent thermal stability of the LEDs, which is very important.
Hey, Keith, got a couple questions. Actually,
absolutely.
This first one, they took the words right out of my head. If it doesn't create heat, why do you need to have cooling?
So there's no heat from the LED to the web. There is heat in the process. If you think about, there's a lot of energy coming into these lamps to push the energy, the light out, right? So there is heat on the back side of the LED, where all of the mechanics and all of the magic happens, so to say. So that's where the heat is manufactured in this process.
Okay. And we have another one.
Yeah.
How is the UV focused on the LED sources? How important is the focus distance on the LED UV units?
It's very important. So, we have a baseline that we start at specific to Flexo, right? And there's a lot of things that you got to keep in mind when you're talking about curing. It's ink film thickness, it is reactivity, it's absorption versus transmissive characteristics of the ink. Is it a clear coat? Is it opaque white with titanium dioxide that doesn't like to allow penetration at heavy ink film thicknesses? Is it black, which is a carbon pigment? But we have a baseline that over the years, we've found that somewhere between 3 to 5 millimeters away from the web is ideal. Now, depending on what you're doing, we can move the LED away to further distances and still achieve a cure at a profitable speed for you, but that's where we start. And it's very important because the further away you go, there's a cone. The light comes out in a cone, and the further away you go from what you're trying to cure, the intensity goes down. So you've got to keep that in mind.
Sure, makes sense. Yeah,
Okay.
That's it for now, Keith, but keep
All
the
right.
questions coming, folks.
So there's a full range of UV LED process solutions available now. In the beginning, when LED was first coming in the marketplace, it was primary like opaque white and 4-color process. Now everything is available, and I'll show that to you a little later in the presentation. But pretty much everything you're doing today in the press room is available in LED. Great satisfaction amongst those who have converted and matched LED to the application needs. So one of the things that Phoseon is very happy to say is we have not placed LED in I'm going to stick to printing because that's the part of the industry that I know. We have not placed LEDs in a facility on a press and had a customer come back and say, this just isn't working for us. Matter of fact, what they do is they come back and they go, we weren't expecting it to be this good. We need to start looking at it for other parts of our process, because a lot of people are slow to adapt. Like I said, they'll start with just an opaque white. So they put one LED on the press and it runs so well. LED opaque white cures at a much faster rate. You're able to put it down a lot heavier and get better opacity. So now, as soon as they get it, they get comfortable with it, they experience it, they see a different light on the press. So now it's blue and not white. Just get used to all the differences and the nuances of the technology. It quickly scales up into we need more, and we need more. Growing numbers of formulators and LED suppliers and OEM press offerings. All of the OEMs now work with LED. We work with all of them. The formulators are all now formulating everything for LED. I do know specifically, and I won't speak to who, but there are companies out there that are now investigating moving forward only formulating LED version inks, because if you have an LED ink, it will also cure under a mercury light. If you refer back to the wavelength chart that I showed you before, that 395 wavelength that we're looking for with our lights is also there in a mercury bulb. So a mercury bulb will cure LED ink. So the formulators are actually saying, well, we don't need to manufacture 2 different ink lines and maintain higher inventory levels of raw materials. We can just move everything to LED and it will work across the board, and it increases our buying power. We can reduce costs. We can, turn around orders to customers faster. So all of things are going that way.
Okay, great. Good
Yeah.
stuff. We got a few questions here.
Okay.
This gentleman would just like to confirm. So you're saying white ink can be cured better with LED?
Absolutely. We'll talk about it a little bit further in the presentation. It has a much faster response rate, and the reason for that is that once again, if you remember back to that chart, the wavelength of 395, it's very intense and very deep. So it penetrates all the way through. You're actually able to cure a heavier, sometimes even double the ink film thickness at a faster rate.
Okay, well, that kind of answers this next one, but we'll ask it anyway. What
Yeah.
about clear and top coatings and like heavy coat weights?
Yeah, so pretty much anything with a heavy coat weight, you're going to get a better response, provided that the chemistry is designed to react at 395 nanometers. So when it comes to coatings and top coats, once again, good depth of penetration and depth of cure. So where all of your adhesion characteristics and everything come into play, which is the crucial part of ink and substrate interface, everything is great. The difference is, if you remember where I said before with coatings, there's a little bit left to be desired on the surface cure aspect on traditional LED coatings, but I'm happy to say that a lot of the formulators are now formulating specific coatings that have fantastic surface cure. They're working with the raw material suppliers with different photoinitiator packs and different photoinitiator precursors that are able to provide a decent surface cure or a desirable surface cure at 395 nanometers.
Okay, now I got to just hit you with a Joe question, Keith. So when we ran the magazine cover or
Yeah.
the project at Clemson, was the only, because we use a regular UV ink
Yep.
or coating, and was
Yep.
that just because we didn't have a LED unit on that print station?
No, there was an LED unit on that print station, but if you remember, respective to that project, there was a request for a specific extreme high gloss UV coating.
Correct.
And at that specific moment in time, the supplier that we used didn't have an LED version available. So we made the decision. Now, in an instant like that, if you were a converter, you could call your supplier, whoever it may be, Siegwerk, Flint, INX, Zeller, whoever, I don't care, and say, hey, we've got a request for a high gloss LED opaque or a LED coating, and they can formulate it for you. And the supplier that we used for that project, Joe, could have done that, but we needed it in a day.
Right.
So we just made the decision to run a mercury coating.
Right. And another question just popped up, but I think you already answered it, but I'll let you just hit it again. And the question is, do special UV inks have to be used for LED?
Okay. So when we say special, you have to use a LED ink. So if you run LED, all you have to do is tell your ink supplier, I need this black and it needs to be LED. Now, the good thing is if it's LED, it will also cure under mercury.
Right.
If it's mercury, it will not cure under LED.
Good clarification. Thanks, Keith. That's all the questions for now.
Okay. So let's talk about some of the positive impacts on the converters. UV LED is more productive, reliable, and repeatable. From a productivity standpoint, it eliminates unplanned line stoppages. If any of you are converters that have mercury UV on your press, I'm sure you have experienced shutter faults. I'm sure you've had to change your bulbs because you were curing poorly and you found out that you had 1,200 to 1,500 hours on the bulb. These are unexpected line stoppages which cost time, money, and productivity. The benefit with LEDs, it's instant on and off. With mercury, you have a warm up and then the bulb has to stay on. So if you're between jobs, if you're changing over jobs for 45 minutes, that bulb sits there in what they call standby mode, which is somewhere around 30% power and the shutter's closed. So you're burning energy that you're not gaining any profit from because it's in standby mode, ready to go. LED, you don't have that. It shuts off and it comes on immediately. Less maintenance for just-in-time delivery, short runs, job changes, increased yields, 10 to 30%, less waste and scrap once again because you don't have any of the unplanned line stoppages, and then more press time. More reliable, once again, less maintenance, quick job changes, short runs, stable and consistent UV LED output. And I'm going to change this a little bit on you. It says 30,000 plus on-time hours with minimal degradation. We've got a life lab in Oregon that we have always got no less than 50 lamps in there testing. And we are now pushing upwards of 65 to 70,000 hours on the LEDs. It's all about thermal stability. So we're able to say in the marketplace, you are able to go in an ideal situation where you take care of your LEDs 30, 40, 50, 60,000 hours. If you think about that, that could outlive the life of your press. And then more repeatable, it's consistent curing. It's predictable, it's consistent, and it's reliable. It's controllable. You can change the intensity. You can actually change the SLMs. If you've got a 16-inch web and you're running, or a 16-inch press, and you're only running an 8-inch web down the middle of the press, you can actually turn off the outside SLMs on certain LEDs and only run the middle if you wanted to do that. Repeatability is essential for low migration printing. One of the things that you got to think about with low migration is as soon as you put a mercury bulb in the press, it starts to degrade. And unfortunately, there's no light, there's no flag that's raised or anything that tells you, hey, this bulb's not curing properly. The way you usually find out is you've already printed it, it's made it to the rewinder. Hopefully it doesn't make it out of your facility. but it gets to the rewinder, there's some blocking, or somebody picks up the roll and they notice that the colors are smearing or something like that. You don't have that with LED because it's a consistent cure. We're talking 50, 60,000 hours as opposed to 800, 900 or 1,000 hours. Press operators can concentrate on printing. That's the big thing, is now you're not worrying about changing bulbs, polishing reflectors, changing shutters, or fixing shutter faults, anything like that. You can worry about, my light's on, let's run the press. Let's worry about registration. Let's worry about how the roll's rolling up at the end of the press and not scoping, stuff like that. You can actually be a press operator. So the positive impacts, lower operational costs and high quality print. So it's more economical. If you think about it, reduced energy, up to 50%. I would challenge that and say it's actually even more. If you take a hot air dryer off a press, you've got multiple dryers and a lot of huge blowers that use a ton of energy. And now you're going to replace it with an LED that is either got a small chiller or a couple small fans on the back of the LED. Reduced infrastructure. So with the beauty of LEDs, you don't need exhaust, right? So with mercury, you have ozone that is being created that you have to exhaust away. There is no ozone with LED. You have air exchange, you have power delivery, and then you have no roof penetration. So when on the backside of the press, when they install your press and they bring in the LEDs and they exhaust the LEDs away and then they cut a hole in your roof, you don't have to do that with LED because there's no ozone and no heat that needs to be taken away. Elimination of lamp-related consumables, bulbs, shutters, and reflectors. I did a study for a customer one time and I showed them over the lifetime of their UV mercury system, they actually pay significantly more for that system than they do for LED because of the reoccurring cost of consumables. UV bulbs are somewhere to $200 to $300 a pop at 10 stations. You replace them every 1,000 hours. That's a lot of downtime. That's a lot of consumables. Improved safety and environmental. There's no mercury. Mercury's big. There's actually a lot of legislation around the world that is particularly honing in on mercury, and it's going to be harder and harder to use it in industrial curing applications around the world. There's no UVB, no UVC right now, and there's definitely no ozone, so you don't have that to worry about. So high quality print, there's no compromise on color gamut. You can actually expand your gamut and print at a heavier or more brilliant ink deposit. Better through cure and adhesion. Once again, penetration of the UV light is all the way down to the substrate ink layer. That's the critical layer for adhesion. Reduced heat transfer to substrate. There's no IR heat. More opaque whites. I like to say more opaque whites because you're able to put it down at a heavier ink film thickness. Truer metallics and brighter fluorescence. If anybody here has ever run UV fluorescence with a UV mercury bulb, you have to specifically place that color somewhere in the press where it's going to hit far less UV lights than it would if you put it at the beginning of the press, because every UV light that a fluorescent hits, it'll fade. And by the time it gets to the end of the press, it looks like a burnout different color. So now it puts restrictions on your graphics and where you can place it in the press, because you always want to put it towards the last station or the second to last station to minimize the number of lights. With LED, you don't have that. You can put it in the first station, don't worry about it, because those LED lights aren't going to impact it and burn it out. So before, where the operators can now focus on being press operators, here the owners and managers can concentrate on growing their printing business. Let's talk a little bit about the ecosystem. One of the reasons that I came on board with Phoseon was to focus on bringing the ecosystem together with LED. So part of my job is to work with the press OEMs and the ink and coating company, and you bring together the whole package to the converter. We work with every one of the OEMs. You see a lot of OEMs on here that you're going to recognize, whether it is on the Flexo converting side or the digital converting side with their small little Flexo machines. We work with all of them. If your current supplier is not on here, ask them. We work with them. And then this is the big part, the ecosystem partners, the ink and coatings program. We work with every one of them. All of the ink companies, all of the coatings companies, big or small, I am in contact with them around the world. We do group seminars. I did a seminar in Bangkok. I've been over to Indonesia doing seminars with ink companies. And I've got a pretty good understanding of their portfolio, which I'll show you in a couple slides. But the big thing here is to understand that we work with them and they work with us. I'd be willing to bet that any of the ink and coatings companies that you work with today is using our light in their lab. We were the first in the industry, and we've been working with these companies and providing with them with lights to do their formulations. And that should give you some comfort as a converter to know that they're formulating their inks and coatings and adhesives with our technology. So the first thing a converter asks me when I go in, I say, LED would be a good fit for you. And they're like, yeah, but I don't know. I'm doing a lot of things today. Can it be done with LED? So if you look at this chart here, the far left column is all of the different coatings, inks, and things that it represents probably 95% of the marketplace today. So process colors, base and PMS colors, opaque white, blast down shrink whites, metallic colors, fluorescence, all the different coatings that you could think about: gloss, satin, matte, tactile, shrink matte, shrink slip, gloss imprintable, satin imprintable, matte imprintable, direct thermal transfer. Then you get into some of the specialty stuffs like soft touch, laser markable, grit, sandpaper, product resistance for like bumper stickers, release coatings for like multi-layer coupon construction, and then primers, and then adhesives. So the customers say, Keith, this is what I'm doing today. Is it available? And I can show them this because I talk to every one of these ink companies and say, look at this. This is probably 95% of what you're doing today. And if it isn't available on here, I don't know if you can see my cursor moving here, but as of when I put this presentation together, this column here is LED Flexo low migration for UEPA, which is a European low food or low migration standard. Currently, when I put this together, there was no soft touch or laser markable OPV for UEPA restrictions. I'd be willing to bet that it is there today. If not, if I was a converter, I could call up my supplier and say, hey, I need a soft touch coating, and it needs to be low migration to meet UEPA restrictions, and they'll formulate it for you. So this piece right here, this slide, puts a lot of comfort in the minds of the converter when they think about switching over, because pretty much everything that you're doing today is currently available LED. There's no reason to not make a jump to that technology. I'm going to take a drink real quick, Joe.
I told you you'd get thirsty.
So the commercial state of narrow web formulations in relation to Flexo, UV LED. So the inks, we're upwards of 300 meters a minute with the improvement over mercury. It's improved strength, cure, and adhesion, and higher opacity. Overprint varnishes up to 300 meters a minute, and sometimes over, equal to mercury. Metallics, we've seen upwards of 210 meters a minute, improved cure and adhesion, and I'll talk about that in a little bit. Fluorescence, 300 meters a minute, brighter with no burnout or fading, so you get nice, bright, brilliant fluorescent colors off the end of the press, regardless if they're in station 1, 4, 7, 8, 10. Low migration, those speeds are driven by your extraction targets and your rate of cure. They're actually, we've seen upwards of 210 meters a minute. Laminating adhesives, as fast as you can run a press. And we'll talk about that. LED is fantastic for lamination. Cold foil adhesives, 60 to 75 meters a minute, which is faster than most converters will run cold foil. And we'll touch about this also, but it's got improved speed, crispness, and fine graphics. Primers, 300 meters a minute, equal to mercury. PSAs, release coatings are the same. And then specialties, they vary depending on your need and market. But one of the things that you need to understand here is you're going to hear the term in the industry, dual cure. My ink is dual cure. It'll cure under LED and it'll also cure under mercury. If it'll cure under LED, it'll cure under mercury. Those formulations are standard these days because that 395 wavelength is there in mercury, compounded by some other ones that are around it. Your LED inks will cure under a mercury bulb. So if you're thinking about making the switch, you don't got to worry about, do I have the right ink in the right station? If it's LED ink across the board, it'll cure. So LED is a must for screen. Rotary screen, deep UVA energy improves adhesion. Once again, if you look at the right side here, that UVA gets all the way down here to the ink and coating layer where it meets with the substrate. That's a critical point of adhesion. And with screen colors, it's difficult to get all the way through that heavy deposit, specifically if it's a black, which is carbon, or opaque white, which is titanium dioxide. Fast full cure of whites and heavily pigmented inks, durable industrial quality, and improved run speeds. We've actually increased run speeds because the cure is better. There's a lot of inhibiting factors to how fast you can run rotary screen, depending on the opening of the mesh, depending on your squeegee, but a lot of times it depends on your ability to cure that heavy deposit. With LED, it cures specifically opaque whites instantly, so you can actually run your rotary screen faster, and that can no longer be the bottleneck to your process. LED for shrink sleeve. Once again, superior opaque whites at higher press speeds. Low IR impact on heat sensitive substrates, allows for thinner and better shrink properties. One of the questions that I get asked a lot is, Keith, do you, if we're gonna go to LED and I wanna run shrink, do we need chill rolls on the press? And my knowledge of ink and chemistry and my background in the market, I will tell you, yes, you do. Reason being is there's no IR heat that is put out from the LED, but there is energy that is absorbed by specific colors. If you think, if you've got a black car that's sitting out in the sun, it's a lot hotter than the white car sitting next to it, because that black car is absorbing a lot of energy. Same thing with black ink. It absorbs a lot of energy, right? Another thing is ink, when it cures, there's actually a reaction within the ink. It's called an exothermic reaction, and it actually puts out a little bit of heat itself. So if you think about running ink, specifically shrink ink, with LED and not doing it with a chill roll, my true answer to you is yes, you can do it, but the operating window of success is so narrow that you're really not setting yourself up for success. I would recommend chill rolls to maintain thermal stability of the web all the way through the press, which obviously is better for cure, is better for registration and everything else. So for aesthetics, cold foil and mirror silver. So VMD, which is vacuum metallized deposition, that's cold foil. And then silver ink is vacuum metallized pigmentation. If you think about it, what you see over here on the right-hand side, these metal flakes, they kind of layer up over each other. And those flakes act like little mirrors. They don't like to allow the ink to, the light, the photon, the energy to penetrate through all the way down to the substrate layer where the adhesion portion is critical. With LED, when we find these holes, the penetration is all the way down because it's a deep penetrating wavelength. With mercury, the wavelength is about half that, if that, maybe a third of the wavelength of 395 LED. So you're not going all the way down to the substrate layer. So with cold foil, what you'll see is you get a better, crisper edge. I actually ran a test where we ran mercury cold foil. We put it on a fingerprint plate. So it had small fine type, reverse type, and a couple vignettes on it. If you think about doing cold foil with a vignette, you're like, Keith, you're crazy. So we did this and we cured it with mercury, and we got up to about 200, 250 feet a minute where the fine type, the reverse fine type started filling in, and the vignette just looked like a big blob. We then switched it to LED, so same adhesive, same analogs, same substrate, same foil. Only thing we did different was cured it with a light. We were able to run 500 feet a minute before it started filling in. And that's because of the penetrating wavelength that keeps everything crisp and clean on the edges. So your reverse type stays open, your fine type stays open, and you're able to actually print a vignette. It's fantastic for this. UV LED offers more energy photons reaching down to the base layer, which is where once again your adhesion part comes in, and then much finer artwork is possible. So this is, I like to show this graph here. because this is also relevant for low migration on the top. But UV LED lifetime on time, we're, like I said, we're upwards of 60,000 hours. We're up to about 70,000 hours now in our lab, and we're almost 90% efficiency after 70,000 hours. And most people don't even run their lamps at 100% power. What you'll see in the industry, in the marketplace with our lamps, is they're running somewhere around 80 to 85% power. So they're not even pushing max power. So where this is only at 90% efficiency now, if you're running at 80%, you're not even reaching that point. So conventional lamps, every 1,000 hours you're replacing these. You think about every one of these at $200 to $300 a pop, 10 stations. That's a lot of cost. With one LED, you have pretty stable, consistent Cure light source all the way through the lifetime of your machine. Like I said before, we have over 50 units in our long-term life lab. We test duty cycles, high temperature, airflow reduction, and stress test parameters. We've got 2 million hours of SLM lifetime testing. That's more hours than any of the other LED suppliers have been in the market. So what affects LED lifetime? I talked about it before with the airflow. It's all about thermal stability. Temperature and current. Pushing LEDs to attain higher output without properly managing the increased thermal load results in premature failure. We could take a chip and push it, we could push more energy out of it. We can, like I said before, we're using the same chips we had for years. We're pushing more energy through them. We're maintaining the thermal stability of the chip a lot better, and that's how we're able to achieve the higher irradiance. We can continue to do that, but if you push the irradiance without managing the thermal stability, you're going to affect the lifetime of the LED itself. Other failure modes are typically related to diode packaging or failure of the components in the system, whether it's in the backbones or in the back of the system itself. And then we have a 3-year warranty on all of our systems, and it's not just the LED itself. We warrant the entire system.
Hey Keith, the question came in, and I'm going to ask you not to answer it, but I'm going to read it. And he said, "We're looking for a good source for dual curable ink. Can you suggest?" And I'll just say what we'll do is I will send these questions to Keith after, and maybe you could answer that person offline, Keith.
I can answer it generically for you without.
Okay, generic is fine.
Yeah. So one of the things that because once again, every converter I go to, they ask about LED and they're like, well, whose ink do you recommend? I don't recommend anybody's ink specifically. I have relationships with all of them, right? So if you're looking for a dual cure ink, meaning an LED ink that will also cure under mercury, is what I understand it to be, all of them will have it, because that LED ink is already dual cure. So all you need to do is contact your supplier and tell them you need an LED ink. They all have it.
Okay, great.
Good?
Yep, thank you.
Yeah, so adding UV LED to your Flexo press, we found that sufficient irradiance for narrow web Flexo is somewhere between 12 and 20 watts per centimeter squared. The faster you go, obviously you have a higher demand for more irradiance. That's why we have 22, 24, 26 watts per centimeter. The biggest market difference is the delivery of energy density. Greater energy density is required for faster press speeds, like I just said. New press purchase, just tell the OEM if you want to buy a new press, just tell them we want LED and we want Phoseon LED. And then retrofit existing presses. We work with the OEM. So if you have, let's say you have a specific press on the floor, we would come in, look at the press, get the serial number of the press, and we would contact the OEM to get drawings and everything, and then also work with the ink supplier in the market. But this is adding LED to your current and new Flexo presses is mainstream and easy to do. We have a couple case studies. Soprano is a customer. They had some curing issues on special paper used for receipt tickets and coupons in their industry. They're a European printer. They wanted to improve productivity while reducing power consumption, and they wanted to get rid of harmful ozone and greenhouse gases generated by their UV arc lamp curing. So our solution, we came in and we retrofitted the press with UV LED. We integrated the air-cooled system that I was talking about, and it increased their press speeds significantly. Their ROI was less than 3 years, They had more press uptime because they had less downtime for mercury issues. They're more comfortable working in an environment. It's a more comfortable working environment for their operators. Less heat, no ozone, less intrusive UV light in their face. And now they can offer new stretch film printing options, which was a market that they weren't even looking at. So some of the key data, they have an extra 30 minutes of production per shift. They had 40% energy savings by changing from mercury to LED. Very minimal maintenance. Really the only maintenance with LED is to make sure the emitting window is clean. And we would recommend just wiping it off on a regular basis. And if ink happens to get on there, you can take a razor blade and scrape it off. And then they increased their substrate availability by 50%. That's how they gave the new application on the stretch film. And then, you know, he said, at Soprano, we care about the environment. The return on investment calculation was quick and easy, energy savings, time saved prepared in the machine, and easy maintenance of LED lamps. And they're very happy. The second one is a customer in Belgium called Desmet. I've had the pleasure of visiting this facility. They had a couple challenges. They wanted to be able to cure multiple layers instantly. They wanted to reduce their operational costs and increase profits and increase the field of printing and die cutting capabilities. So the solution was Mark-Andy Press with a fully equipped Phoseon LED solution. They have the water-cooled version versus air-cooled. It was easy to implement, easy for the operators to use, instant on-off, no bulbs, and reduced maintenance. So the benefits to them was they now have 32 printing stations with LED curing. They have 5 presses now that are all LED. That's their only curing capability. 75% less temperature in their machines. Possible to cure multiple layers in record time and high quality of printing. They're very happy. They're an all LED facility, and they've made the leap and they've never looked back. So maintenance, like I said, maintenance is simple. Keep the emitting window clean. That's it. Keep the air filters clean if you have a air-cooled system. If you have a water-cooled system, maintain the chiller reservoir with distilled water and corrosion inhibitor, just like you would your Flexo press that has a chilled system on it. Maintain the reservoir temperature to factory recommended settings. And periodic measurement of UV LED output. And we would do that. Measuring UV LED is different than measuring mercury. That's something that we would do. We would come out if you had any questions and measure it for you. Or we could, you could send the light back to our lab where we have full integration spheres that do total UV measurement. But the maintenance on these is very simple. There's no shutters, there's no moving parts. There's no consumable bulb, no reflectors, diachroic filters, quartz lenses, shutters, or anything that you're going to be replacing. So match UV LED to your application needs. Not all market offerings are equivalent. Each application is a UV operating window defined by wavelength, irradiancy, and energy density. A sufficient peak irradiance is necessary for penetration and to counter oxygen inhibition at the surface. A high energy density is necessary for faster press speeds and improved depth of cure. UV LED shrink can be used without chill rolls, chill rollers, or chill plates. However, like I said, the process window is very narrow. Normally, it's recommended that chill rolls, rollers, and plates be used. I actually polled about 5 or 6 of the large major global ink companies in the industry and asked them. They're not press manufacturers, they're not substrate suppliers, but I asked them, I said, would you recommend chill rolls if you were running LED for shrink? And every one of them came back, said yes, because of their experiences, because they know what color absorption will do to heat sensitive films. And they also know about the exothermic reaction that happens when the ink's cured. So you can do it, but it's a very narrow process window and your operator will probably struggle. And then viable UV LED formulation, ink, coating, and adhesives exist and cure with LED at speeds over 300 meters a minute, but not with all LED systems. Do you have a question, Joe?
There is. Oh, you're onto the blinking now, aren't you?
Yeah.
Yeah, here it is. Do you have nitrogen purged units? Are there applications where nitrogen charged units are recommended?
So we don't currently have nitrogen inerting, but that's something that we're working on. And Nitrogen inerting is interesting. The biggest cure inhibitor is oxygen, right? So if you think about coatings, that short wavelength that we're missing, if we could purge with nitrogen, there wouldn't be the necessity for the short wavelength. So nitrogen is good in respect to coatings, but it's not necessary today unless you're maybe running something like low migration.
Okay. Okay, another one for you. Is the unit sealed? In a dusty environment with water cooling, is there a concern of getting equipment dirty?
So the LED, the water-cooled LED itself is completely sealed. There is no way for any dust, there's no way for water, ink, or anything to get in, to egress into the equipment. The emitting window itself is actually sealed all the way around. So you don't have to worry about, if you drip ink on it, I would recommend getting the ink off, but that's just normal housekeeping.
Yeah.
Sit there. But if you drip ink on the light, it's not going to make its way into the SLM cavity because the entire unit is sealed.
Right. Okay, and we have another one.
Yeah.
Some normal UV inks cause excessive plate swell. Would LED UV inks reduce this swell? Have you seen any unique issues where using typical Flexo plates with LED UV inks?
So if you think about UV inks versus LED inks, they are, for all intents and purposes, exactly the same, right?
Mm-hmm.
So it's a monomer, oligomer, resin, photoinitiator, and pigment. The only difference in the two chemistries is really the photoinitiator, what kicks off the reaction. So the plate swell issues that you would normally see in the industry, a lot of them have been alleviated with the reduction of harsh chemicals like HDODA and TMPTA. They're not available in LED either. So the only change or the difference between the two is the photoinitiator, and that is not going to cause any issues at the small percentages that it's at either. So LED is not going to be any different than a mercury ink on plate swell.
Okay, good. And that's it?
That's it?
Yep, for now.
All right, I'm winding down here. So a couple of the misperception in the industry is formulations do not exist for LED. That's not true. I showed you in the previous slide that pretty much everything you're doing today is available in LED. Systems with the same peak irradiance cure the same. They don't, because the energy dose comes into play. A higher irradiance always improves cure. That's not true either. You need to worry about dose. Blended UVA wavelengths improve cure. Now, there's some talk in the beginnings is, should we take 395 and blend it with 365? And what they've found in their testing is that while the wavelengths are different, they're so close that there's really no benefit gained by doing that, because now you've got to look at different photoinitiator packages and blending them. So there was really no benefit to that. LED formulations have poor adhesion. That's absolutely false. LED formulations actually have the best adhesion. I've got a friend of mine that works for an ink company, and he said that one of the things he likes about LED and LED formulations is if he goes in there and they're having what they perceive as an adhesion issue, he knows that if it's LED, there's almost a 99% chance that it's related to the material, because LED formulations have fantastic adhesion because you get full penetration of the wavelength all the way down to the adhesion layer, which is critical. LED formulations cause viscosity, spitting, and slinging issues at high speed. Like I just said a couple minutes ago in answering Joe's question was, for all intents and purposes, the formulations are the same. The only difference really is the photoinitiator package. So the LED version is not going to cause any specific viscosity, spitting, or slinging issues because it's pretty much the same. LED is expensive up front, but with too long of a payback. Not true. You saw Soprano had a 3-year payback, and we're able to show in some instances where you can actually obtain a less than a year ROI payback. All of those are incorrect. So in summary, UV LED Flexo is a viable technology for a new press or a retrofit. Bring one of your old presses in your facility back to life today. UV inks, coating adhesives are widely available today for LED. It's better suited for low migration with consistent cure levels and instant on-off energy. There's no better light source for low migration than LED. It's consistent, it's predictable, and you get an even cure all the way across the web for the lifetime of the machine. Groundwork has been laid. UV LED Flexo is poised to explode. The industry is going to flip to LED. My fear as a supplier in the industry is a big part of the industry is going to wait, and there's going to be the switch is going to flip overnight. And unfortunately, you can't make a very high quality LED system overnight. So what it's going to do is it's going to push the lead times out to extraordinary lengths because everybody's waiting rather than getting on board with the technology today. By 2021, UV LED will be mainstream. I'll say it's already mainstream. If you talk to the ink and coating suppliers, they're formulating for it. Successful applications require the correct UV LED solution to be matched to the needs of the press. Phoseon, our ecosystem partners are ready to address your needs. So your OEM, they know about Phoseon, they're ready to do that, and the ink suppliers are ready to formulate for it. And UV LED market offerings are drastically different from each other. Thank you very much.
Wow, Keith, good job. You know, I would point out for everybody here too that if you want to see a sample of something that was printed full LED, your October issue of Flexo magazine has a pull-off piece on the front cover of it. That piece was actually done on a Flexo press with LED lamps using LED exposed plates. So you can everybody can kind of get a look at that. Keith, thank you very much.
Thank you.
What a great presentation. A lot of good information, a lot of good questions came through.
Yeah.
If anybody has any questions for Keith that they didn't want to ask here, his email address is on the screen. Feel free to reach out to him direct. And as I mentioned to all of you earlier, this webinar has been being recorded, and tomorrow morning you will receive a link to that recording. And also I want to invite everybody back for the webinar that we'll be hosting on December 12th with 3M, where they'll be talking about optimal, consistent, and productive mounting tape selection to improve all aspects of your flexographic printing process. So keep an eye on your emails for that. And once again, Keith, thank you. And to all of you, thank you for joining us today.
Thank you very much. I appreciate the opportunity.
You bet. Take care, everyone.